Hello and welcome to this lecture on vector calculus. In this video, we are going to solve a problem on Gauss divergence theorem. So first of all, we see the statement. So here, it simply gives a relation between a surface integral to a volume integral. So if V is a closed volume bounded by the surface and F vector is the vector field with the continuous partial derivatives, then we can write the surface integral which will be equal to the volume integral, where n cap will be the outward normal unit vector on the surface. We shall move over the problem. They have given a function f vector over a cube bounded by the planes. So they have given x equal to 0, x equal to 1, and y equal to 0, y equal to 1, z equal to 0, z equal to 1. So there is a cube with the unit 1. Okay, so we may draw a cube with these values where this represents x, y, z, x, y, z. So with this, we may draw a graph like this. It is a cube with the three axes x, y, z. So of course it is a 3D, so three variables, three dimension. And here totally six faces are there. So we may say that is surfaces. This will be the first surface. Here x will take the point 1. Other than that, y and z will be of 0. And the second surface here x will be of 0. Okay. So here, how do you say this? Just see that this will be the first surface. In this, all the values of x will be 1. Okay. If you go for the second surface, see, second space, this is a second surface. This will be the first surface. See, y here, x is 0, 0, 0, 0. All four coordinates are 0, as same as this will be s1, this will be the s2, here x equal to 0, and here this will be the third surface, here y will be equal to 1, this is the fourth surface, here it is s4, y equal to 0, and this will be the fifth surface, here z will take the point 1, z will take the point 1, 0 comma 0 comma 1. Okay, so this will be the sixth surface, here z will be equal to 0. So with this we are going to verify the given Gauss divergence theorem, where a red arrow shows the outward normal on the each surface. Now we shall go for the RHS. First we will evaluate the volume integral, that means a triple integral. What will be the formula for it? We know that triple integral over gradient dot f vector dv. So first we will find the triple integral. We will find the gradient f vector. Gradient f vector means it will be f1x plus dou f2x y plus dou f3 by dou z. So where f vector will be f1 I vector plus f2 j vector plus f3 k vector. So in this given equation, it will be x square I vector plus y square j vector plus z square k vector. Okay, so we have taken this alone, x square y square z square. On differentiating with this respect to x y z, we make it 2x 2y 2z. So next we are going for the evaluation on triple integral over this. So here x, y, z, all the three variable are varying from 0 to 1. So how do we evaluate this? Because it is a unit cube. So 0, 0, 1, 1, 1, and here the function will be 2x plus 2y plus 2z with respect to dx. First we will evaluate this internal integral. So on the evaluation, what will be the value? You are getting this? I have to integrate with respect to x. So it will be 2x square by 2 plus 2xy plus 2xz 0 to 1 dy dz. on the next step, how it will be on substituting the limits 2 it will get cancelled 0 1 1 x square plus on substituting the limits. After substituting the limits, I may get 1 plus 2y plus 2z, because we have to substitute the limits for x values alone. So on the next step, we will differentiate this function with respect to y. So here it will be y 2y square by 2 2yz, and substituting the limit 0 to 1 dz, and here it will be 0 to 1, then 1 plus, here also 1 2 will get cancelled, and 2z on substituting the limit 0 to, while I have substituted z. Now we have to integrate this with respect to z. So it will be z 2z square by 2. So here 2 will get cancelled, 0 to 1 again. So 1 plus 1 equal to 3. So this will be the RHS. Okay. Now we find the value 3. Next we are going to find the LHS part. LHS will be of double integral over the surface f vector dot n cap ds. So I am listing a table. The table format will be the first column surface n cap, that normal vector, then f vector dot n cap, which is needed for this evaluation, and we need equation to substitute in this formula, and at last we have to decide on the s and about the variable with the limits and final value. With respect to each surface, we are going to evaluate like this. First, I may take the first surface. The first surface will be S1. Here the equation will be x equal to 1, because here there are 4 points. In all the 4 points, x will be equal to 1. Then what about y? What is the y axis? This is the y axis. So y varies from 0 to 1. Y varies from 0 to 1. And what about the z? Here it is 0 to 1. See, 0 1. So y and z varies from 0 to 1, and here the equation is x equal to 1. So first I may take f vector. What is the f vector they have given? X square plus y square plus z square with the ijk. Now this is the first surface. I am finding a normal vector outward. Now it will be on the x-axis. X-axis represents I vector. So the normal vector is I vector. While multiplying this both, I may get I vector and I vector as 1. What about the remaining I vector into j vector, I vector into k vector will belongs to 0. So I may get only x square alone. So on which, after finding this, I have to write the value of x. Okay. So I have to substitute the value of x in this equation. X is equal to 1 means, what will be the value here? If I will get 1 again. And what about the variables? Here we fix the x equal to 1, and here y and z are the variables. So dy dz, ds will be dy dz. Then we find f vector dot n cap and we find ds. We have to substitute in the final value with respect to the surface S1. Then we may substitute it 1 dy dz. I mean, on integrating this, what will be, how do you get 1? Simply I may integrate this 1 dy 0 to 1. On integrating this, integration differentiation will get cancelled. Then here it will be of y 1 0 dz, then 0 to 1 dz will be there. So z 0 1, finally I will get 1. That's why we getting 1. So how I am going to fill in the first row? N vector, it will be I vector. N cap normal vector will be I vector. And what about this f vector n cap? It will be x square. And what about this? After substituting the equation, here this equation will be in all the points x will be equal to 1. So I am equating x equal to 1. And if you go for this on substituting s, so I may get, after substituting x equal to 1, I am getting that equal to 1. So I am writing that it is 1. What about ds? Here the variables are y and z. So here it is y and z. While after the final evaluation, I am substituting this, I am getting 1. That's all. Similarly, we go for second surface. Second surface, now left face. So this will be the second surface. Here, if you see this, all the points will be, how it will be, 0, 0, 1. Here 0, 1, 0. 0, 0, 1. Here this will be 0, 1, 1. If you see here, all the x values will be equal to 0. That's why I am taking that x equal to 0. Okay, so here according to this S2, the normal outwards will be opposite to x-axis. X-axis represents I vector, opposite na minus I vector. Then as same as that, our the f vector will be x square I plus y square j plus z square k. While substituting on this equation, I minus I vector into x square na I vector and I vector will become belongs to 1. X square into 1 na x minus. So I vector it will be of. So how do we get this? X square I vector into minus I vector. I vector belongs to 1. Here it is minus na minus x square will be the final answer. Then what about the equation in the surface? X equal to 0. Just substitute x equal to 0. So here it is x square. If I substitute x equal to 0, it becomes to 0. What about the variables? See here, this is a y axis. So y varies from 0 to 1. 0 to 1. So y varies from 0 to 1. If you see the z axis, okay, here the x will be the equation. Other than x, the remaining are all variables. So if you see the z axis 0, 1. So 0, 1. For both of the value, I am getting 0. Then how do you fill this column? N cap, it will be minus I vector. Then in the surface, it will be of x square minus x square is there. So I'm substituting over here. After substituting, taking this equation x equal to 0, I'm getting 0. So 0. What about the variables? Y and z, final value is 0. That's all. Then we go for the third surface. It will be top front face. It will be S3. Here, if you see this, here it will be of 0, 1, 0. This will be 1, 1, 1. And here it will be 0, 1, 1. And this, here it will be 1, 1, 0. Okay. If you see this, can you feel y equal to 1? If you see all the points, y will be remain a constant in all the 4 coordinates. So y will be equal to 1. And what about the remaining? X and z are the variable. Then if you take this surface, now it will be along y. Y axis represents I j vector. So here I am taking j vector. Then you just multiply f vector with j vector. There will be y square, and the equation is y equal to 1. So after substituting, I may get f vector n cap equal to 1. Then after the evaluation, I may get 1. Then I will fill in the third row as same as the data what I have get in the book. Then we go for S4. S4 will be just opposite to S3. Here what will be the points? Here it will 1, 0, 0. Here it will be a 0, 0, 1. Here 0, 0, 0. And here 1, 0, 1. If you see this, all the y coordinates will be 0. So I am taking y equal to 0. And here the normal will be outwards. Normal outwards, it will be opposite to y. Y represents j vector. Opposite minus j vector. So I am taking minus j vector. Then as same, multiply n cap with the f vector what they have given. Here it is minus j vector. So I am getting minus y square. Then what about the equation here? It is of y square equal to 0. So I am taking substituting the value y equal to 0. Finally, I am getting the f vector dot n cap as 0. Then here the variables are x and z with the limits from 0 to 1. So if you see x 0 to 1, if you see z, it will be of 0 to 1 again. So at the final evaluation, I'm getting 0. So now we go for S5 at top lid. So here, if you see this, how it will be 0, 0, 1. Here it will be of 0, 1, 0. So therefore 0, 1, 1. Here it will be 1, 1, 1. So here 1, 0, 1. So you just see this, all the z values are equal. That means it is equal to 1. And here the normal vector will be outwards, is just opposite to the, just along the z axis. Along the z axis is a k vector. So n cap normal vector will be k vector. You just multiply with the f vector, you will get z square. Then here this equation is z equal to 1. So after substituting here, I may get 1. And here z is a constant. Other than that, x and y are the variables. So I am taking the dx dy, where x varies from 0 to 1. And if you see y varies from 0 to 1. So after taking the limits, after the evaluation, I am getting 1. Then we move for the sixth surface. Sixth surface will be a bottomlet. So here, if you see this, here it will be a 1 comma 1 comma 0. Here this will be 0 1 comma 0 comma 0. Okay. Here 0 comma 1 comma 0. This will be origin. You just see all the z values are 0. So I am fixing that z equal to 0 in the plane. So here it is opposite to the z axis. Opposite to z axis. The normal will be opposite to z axis. The z axis will be correspond to k vector. Opposite na minus k vector. While substitute multiplying with the f vector, na I am getting minus z square. Then here the equation is z equal to 0. So I am after substituting here, I will get 0. With sz is fixed on x and y are the variable dx dy. Here x limit is from 0 to 1 and y limit is from 0 to 1. Therefore with this limit I'm getting 0. So finally we find all the values with respect to all the 6 surfaces. So if you add up all the 6, I'm getting the value 3. 1, 1, 1. So finally RHS and LHS are equal. So this is a RHS part, this is LHS part. So finally it is equal to 3. Hence the Gauss divergence theorem is verified. And I am giving the exercise. Here you just take the simple problem. 4zx I minus y square j plus yzk. With these points, it also makes a cube. And the answer will be both LHS and RHS will be equal to 3 by 2.